Hi, and welcome to Talking Tech. I'm your host, Alejandro Hoyos, and today we have the pleasure to actually have a great friend here with me, Jonathan, and we're going to be talking about the latest workstation processor, Xeon 6. So Jonathan, tell us a bit about it, and great to have you.
Hey, thanks for having me. Yeah. So Xeon 600 processors for Workstation, codenamed Granite Rapids Workstation, unleashes heavy-duty computing by combining a server processor with a client chipset, so you get a bunch of connectivity options, Wi-Fi, with the heavy-duty compute of the server Xeon 6 processors. So it's fantastic.
No, that's pretty great. And one of the things that I wanted to ask you, so Workstation, for those who are like kind of new to this, who is Workstation for? Like, what are the people that should get this type of processor?
Yeah, so workstations are a super high-end class of processors and platforms there. They're really designed to help accelerate advanced computing, things like computational fluid dynamics, things like finite element analysis, more in the engineering sphere, where they simulate how air kind of goes over a car, for example. These are high-end platforms really to help with those large simulation tasks, as well as high-end 3D rendering as well. So these are just super high-end platforms, really for those business class users who need the highest end compute to get their job done.
Oh, that makes sense, like engineering, research, science, all those kind of things.
Exactly,
so,
yeah.
That's pretty neat. The other thing that I noticed with this one, Granite Rapids and there's a new naming convention, actually.
Correct,
It makes it a little bit easier, or at least for me, a little bit easier. Can you tell us more on that?
Yeah, so our previous generation was called Xeon W processors, and we had two sets of processors, Xeon W3500 and Xeon W2500. With Granite Rapids, we're simplifying it to just one product SKU stack, so it's just Xeon 600 processors for Workstation, and we have multiple SKU options in there, so it's a little simpler just to kind of help just overall with simplicity there.
Okay, no, that makes sense. All right, so now let's talk about what everybody's kind of looking forward to. Let's talk about speeds and feeds. So what does this guy bring to the table?
Yeah, so Granite Rapids brings, it's built on Intel 3, and it's built with Redwood Cove cores. And so Redwood Cove brings a whole host of additional L3 cache, as well as additional efficiency when built with Intel 3. And so that allows us to fit more cores in the same TDP envelope. So we can fit up to 86 cores in 350 watts, where we only had 60 cores on our previous gen platform based on Sapphire Rapids.
That's great. So that probably makes a big difference when it comes to multi-threaded applications, right? Because you're increasing the amount of cores that you have there, but I think you also have made some changes and also improvements when it comes to single thread.
Yeah, correct. So there's some single thread improvements there. I believe it's about 9% better performance there. And that single thread performance is more coming from the bigger L3 caches. Right. But then from a multi-threaded standpoint, obviously we're going to get more multi-thread performance with an 86 core processor. And I believe that's about 61% more performance over the 60 core processor based on Sapphire Rapids previous gen.
You keep saying L3 cache, which is pretty interesting. What type of applications? And I'm afraid I'm going to have to say this word, but I think it's like AI, right?
Yeah, so definitely a lot of big data science workloads. As you bring data closer to the core for computing, either for doing CPU AI inferencing or for CPU analysis there, which is a step before you're training the model, where you're kind of cleaning up the data and looking at it from different ways. That L3 cache can really help with those type of workloads. More data science, not necessarily making AI inferencing faster, but more kind of the data prep before you're training your AI model, either on a CPU or on a GPU there. And so it'll also help in other areas. So computational fluid dynamics really helps with from L3 cache, but also in financial services, where the data set can get closer and closer to the CPU. And when you reduce that latency by moving the data closer to the CPU, your overall performance increases there. So we're seeing great performance in financial services workloads as well with Granite Rapids here.
No, that makes sense, because you're bringing all the data, I guess, what back in the days what we used to call in-core instead of out-of-core.
Exactly, yeah.
So that's pretty neat. Since we're talking about memory, there is we have a pretty good amount of options on I/O when it comes to Granite Rapids.
Yeah, definitely. So we have, from an I/O perspective, we have up to 128 PCIe Gen 5 lanes. So in theory, you can connect 8 graphics cards, 8 full-sized Gen 5 graphics cards. If you can find a chassis that can do that, please let me know. I'll build one. But no, it's super fantastic from an I/O perspective. From a memory perspective, we also have up to 8 channels of memory capacity and we support up to 2 DIMMs per channel. And so that's fantastic from getting higher DIMM capacity and higher memory capacity. I think we can go up to 4 terabytes of memory capacity there, which is super helpful for large data sets if you need to load that into memory instead of going from storage to the CPU there. So if you can fit that entire data set into memory with that 4 terabytes of memory, it's just going to increase your performance a lot. We also have support for MR DIMMs, which are multiplex ranked DIMMs there. And so that will also more support for like high memory bandwidth, meaning that you can have high memory speeds there. So I believe we go support up to 8,000 megatransfers per second on Granite Rapids. So very high speed memory there for registered DIMMs there. Nothing on like compared to client DIMMs, kind of desktop DIMMs. But on our DIMMs perspective, supporting up to 8,000 megatransfers, super fast, super fantastic for memory bandwidth workloads. Those 3D rendering pipeline that I mentioned a little bit before, definitely financial services, definitely FEA and CFD workloads there. So a lot of great things from both an I/O perspective and memory channel perspective.
I mean, the 8,000 megatransfers per second on a workstation, it is pretty impressive. So, I mean, it's nothing not to sneeze at, but I think it's really good, and especially with the capacity that you have right there.
Definitely.
It is great. All right, so you guys have a whole stack. Let's talk a little bit about the stack. How does it work and all the different features it comes with? Yeah,
so Granite Rapids features all the way from a 12-core option at the bottom end for about $500 there, all the way up to an 86-core processor, the Xeon 698X, and that is about $7,700 there. And so, we have a lot of SKU options. Some of them are unlocked. We have X SKUs, which are unlocked processors. We'll talk a little bit about that later. But then we also have options for different memory channels. So there's some motherboards that would maybe support only 4 memory channels. So we have SKU options for those as well, more in the lower core count. But yeah, we have a huge range of options. And we have a huge range of options there to really scale with business needs. So we don't want to like create huge gaps where someone would go from like a 16 core up to a 32 core. And then that's a huge price jump and not have options for them in the middle to kind of meet where their business needs are there. So yeah.
No, that makes sense. Okay, so before we jump into overclocking, because I really want to talk about that, there's 2 things that I want to touch on. First one, it's on vPro. So tell us a bit about vPro for those guys who, are IT professionals that want to know what features does it bring or how it supports it.
Yeah, so the wonderful thing about supporting a client chipset gives us the Intel vPro feature set. So that's things like active management technology, things like security and manageability technology. There's a whole host of vPro technologies that's under that umbrella. And so this platform is a vPro platform, meaning you can activate vPro just like you would on other platforms. And what it does is it gives IT the tools it needs to keep the workstation up and running for those professional users in that business context. So if you have a whole host of systems, like 1,000 systems, some of them are laptops, some of them are desktops, well, these workstations can be managed just like any of those laptops or desktops there because it has that client chipset.
No, that's pretty impressive. And one of the cool things, the other thing I want to talk to you is like, this also comes box, like it's a box processor. So for all those DIYers that wanted to actually go and play with it, we can actually go ahead and do that.
Yeah, for those DIYers who are near and dear to my heart, yes, we do have box processor options. We go all the way from like a 24 core all the way up to the 64 core options. And so we do have box for individual retail. And within those boxes will also be package carriers. These are carriers that you attach to the CPU to attach it to a thermal solution as well. So that's all included, makes it a little bit easier for the DIY crowd to be able to build their own workstation or develop maybe a server based on Granite Rapids.
Okay, that makes a lot of sense. And some of these box processors that we have there have the X suffix, right? So that means overclocking. So okay, now let's talk about overclocking. Where do we are here with this?
Yeah, so from an overclocking perspective, it's a historical thing we love supporting on Workstation, all the way back from the Core X, Intel Core X series days. Back then, I think you remember that as well. And so we brought that kind of feature set forward. And so there is a whole host of overclocking features that we've enabled. We've enabled it with a bunch of different software tools to be able to address that overclocking mailbox, so you can overclock while you're in the OS as well. And so we have like per core overclocking. You can overclock the mesh frequency that connects all the cores together. You can overclock even the frequency that connects the compute tiles together, because we have multiple compute tiles on Granite Rapids. So we have a whole host of overclocking features, but also we have new reporting features. So let's say, for example, you're overclocking and you don't know why you're not able to hit a certain frequency or a certain voltage there, we have new reporting tools that will actually tell you why before the system blue screens of like, hey, you're thermal limited or you're voltage limited or any kind of reasons there. So with Granite Rapids, we increased the number of features, but also they were super excited on the overclocking features that can be brought there. And I'm super excited about some of the overclocking world records that we broke with Granite Rapids as well.
Yeah, actually, the one thing that you brought up that is pretty, that I forgot because I dabble more on the consumer side. And what we have there is mostly like the ring, right? The cores are on our rings and on the sub, but now you said like mesh. Like mesh is a completely different structure that we have there.
Yeah, so it's a different microarchitectural structure. And so what a mesh architecture does is it's all connected, every single core is connected to every single core. And what that does is it helps reduce latency on moving data or copying data from a core to another core. And so by having a mesh frequency where every core is connected to every other core, it kind of reduces that latency and overall increases performance on those latency sensitive applications there. If you, let's say if you have, for example, an 86 core processor and it's in a ring configuration, it would take a long time. Let's say if you have a core here and another core over here and it has to transfer data all around the ring to get to that other core, that wouldn't be very efficient. And so this mesh architecture layout for Granite Rapids, and we've had it on kind of Xeon class processors before, really helps with reducing core-to-core latency overall. And so the overclocking features allows you to overclock that mesh frequency to increase the performance or decrease the latency, if you will, from each core to core.
That's pretty impressive. And you also said you can actually do, because we have different tiles, you can do die-to-die also overclocking to make sure that...
Yeah, correct. So these tiles are connected via EMIB. And so you can overclock the frequency at which that communication happens in between the core tile, and then even the IO tiles on the top and bottom. And so you can overclock that, obviously, all the other wonderful things about overclocking there, but you can overclock that frequency to get even more performance there. And really, when we're thinking about overclocking in the workstation context, we're giving system integrators the tools to be able to customize the workstation, the performance of the processor for whatever application that they need. Let's say it's a high-frequency trading workload, and they want a whole bunch of high-performance cores running at the same time with a super high frequency. They can do that pending any thermal limitations or voltage and power limitations. But that's why we really do a lot of overclocking enablement on Workstation, is to give those system integrators the tools, or even DIYers who love doing enthusiast overclocking, the tools to be able to tune their processor performance for what they need, for what a particular application is.
No, that's pretty impressive. It actually sounds like for the overclockers, there's a lot of features, there's a lot of knobs that it can turn on, so it sounds like a pretty fun processor to try to go and play with when it comes to overclocking. Yeah, and we partnered with Asus to host like an overclocking event as well. And I believe they broke 10 world records with the 86-core, the Xeon 698X processor. And I believe they had about 10 global first place records as well. So that's the best in kind of the core count class that we have there. So super excited about the level of performance that we're bringing with Granite Rapids and all the wonderful overclocking records. I can't wait to see what all the other workstation professionals do with Granite Rapids when they can get their hands on it. No, this sounds like it's a great product, and I can't wait to see it. When can we wait for it? When can we actually get to see it? Yeah, so we're announcing kind of in the February timeframe, but we'll have broad availability more in the March timeframe. And that's just coming from things like Dell, HP, Lenovo, as well as our motherboard partners, Asus, Gigabyte, and Supermicro, who will have designs out there. And so we're super excited to kind of more the end of March for that kind of timing for when folks should be able to buy it themselves. Awesome. Jonathan, thanks so much for being here with us. I appreciate it. Thank you. I can't wait to play with that processor. Yeah.